I'll be very honest about this topic. I have a lot of passion teaching this topic because I used to not like this topic when I was a kid. And then one upperclassman talked to me, asked me, "Hey, what math topic are you learning?" I said, "Log." I said to him, I don't like it. And he said, "Log, it's easy." I said, "No, it's not." And then he said, "Well, it's just some rules that you follow." I was like, "Yeah, that's the point." Okay. Now, and I would tell you this: if you ask a bunch of math students, they probably would say they don't like log. And then after taking calculus, I have a renewed appreciation of log, which I was like, okay, that's something I didn't know when I was in high school. And I will show you next Tuesday why log is such a beautiful thing. But for today, okay, I will tell you how easy it is. And the way I approach this, it's going to be different from many teachers and textbooks. And my approach is not special, actually. My approach is actually very simple. Remember how we have inverse functions? And we say, well, what do inverse functions do? You do? Do you know? What do inverse functions do? Okay, now if you're blanking, I would say that lies the first problem. You got to build your conceptual understanding. Square and square root, they are an example of inverse functions. Okay, and what do they do to each other? They cancel each other out. Okay, that's why we say cube and cube root, they are inverse functions. So when we learn about inverse functions, one critical element that you as a student, you need to hang on to is that they cancel each other out. Okay. Now, and when we say log, what's log? Well, log, it's an inverse function of exponential function. That means it will give us the ability to cancel something out. Cancel what out? It will cancel out the exponential function. Now, I always tell students, I would say, if you play with the calculator, all right, this is log base 10 of 10. Okay, so now at this moment, you probably don't know what log is. It's okay, but that's why you want to pay attention here, not being distracted. If you type log 10, it's 1. If you type log base 10 of 100, it's equal to 2. If you type log base 10 of 1000, it's equal to 3. If you type log base 10 of 10,000, it is equal to 4, and so forth. So if I ask you, can you explain how we get 1, 2, 3, and 4 for these 4 answers? To find the exponents, or if you're not like learning the exponent stuff yet, you may say, oh, it's because of the number of zeros. Like 10 has 1 0, 100 has 2 zeros, 1000 has 3 zeros, and 10,000 has 4 zeros. That would be correct too. Wait, why would we have 4 zeros? Because we have 10 times 10 times 10 times 10. 10 multiplies itself 4 times. So the first thing I want to make sure is that you learn how to read and translate what you're reading. So when we say log base, this notation, log 10, 100 thing, the way we say it is log base 10 of 100. I want to make sure that you are not looking at this as a multiplication. This is a function. Okay, it's log base 10 of 100. Okay, so now can you go ahead and translate this? All right, and write the translation of this notation on the line given to you. It is. We will say this log 10, 1000 thing, we will translate this as log base 10 of 1000. Okay, now we'll see a lot of different logs in the, well, if you just flip to the next page, you see a variety of logs. But I need you to learn how to say it. If you don't know how to say it, well, you have a little model right here to learn how to say it. Okay, and when we are using log function, it's like asking a question: what is the exponent of 10? And 10 being the base right here of the number. When the number is 100, and we say, oh, it's 2. So what's the exponent of 10 when the number is 1000? Okay, so now I also like to give you a little thought question. Okay, can you imagine, given that log base 10 of 10 is 1 and log base 10 of 100 is 2, can you approximate log base 10 of 50? Can you try to approximate? Give me a good gut choice. What do you think? Log base 10 of 50. Approximately what number? Like less than 1, take a fraction? Well, now think about this. Log base 10 of 10, it's 1. Log base 10 of 100, it's 2. You say 1.5? All right. Anybody would suggest any other number? 1.5 is a good choice, but any other suggestion? 5 would be a bit challenging, because think about this. Log base 10 of 1000 is 3. So if you say 5, the number inside it would be like 100,000. That would be like huge number. So log base 10 of 50 is about 1.5. Let's go ahead and find out what it is. Let's go ahead and find out what it is. We type in log base 10 of 50. Let's see. Anybody want to suggest something other than 1.5? No? It would not be possible to be 0.5 because log base 10 of 10 is 1 already. Okay? Close to 1.7. So pretty good. Okay? What does this 1.69 number mean? So 10 to the power of, oh, sorry, my bad. 10 to the power of 1.69897. Are you ready to see the answer? 50. Okay. So I want to make sure that you know what the answers are meaning. As I always say, you got to know the meaning. Don't just focus on the doing. If you focus on the doing part, you're in big trouble. Okay. So we are simply asking, what is the exponent of 10? And now, how do we get the answer? Now, I know the calculator can give us the answer, but how can we get the answer if I give you some nice numbers? Like, how do I know? How do I get log base 10 of 1000 equal to 3? And this is how you do it. You basically rewrite the number 1000 as 10 to the third power. And why? Because can you see the base of the log and the base of the exponential functions? They are the same. It's like, hey, you want to cancel out the square? What do? You do a square root, not a cube root, not a fourth root, but a square root. They gotta match up. They gotta be the inverse, exact inverse functions of each other, and therefore they can cancel each other out. And that's how you get 3. All right, so today we are going to rewrite some numbers and show our cancellation. And that's how you're going to make yourself a very easy life.